My name is Claude Poole, and I would like to present to you the latest refurbishment and installation of a tube mill done in the USA. Been upgraded to a laser line. We're able to achieve greater speeds and higher quality output in various grades, A249, A269, A270 particularly. Installed on this line are a Refurbished 6 kilowatt laser, a seam grinding system, internal bead rolling, particularly for the A249, A270 products. It has inline bright annealing and also cold cutting with a bandsaw. Of course, all the shafts, all the bearings, all the seals have been replaced throughout the mill. We paid a lot of attention to the selection of the well box, laser and bead rolling systems with the idea of achieving a higher quality of A249, A269, A270 products. This is the Refurbished beam delivery system, and it has 5 mirrors which deflect the beam out of the resonator, and eventually the beam is transferred through the series of 5 mirrors, and we quench just behind that to have the tube retain its form so that it doesn't deflect too much before we go into the bead rolling system. Overall, the beam delivery system, the resonator and the power supply fits on a very small footprint, and it's practical and user-friendly for maintenance, user-friendly for the operators. Moving on, I want to show you the control panel, which as you can see is on a swing arm, and this makes it easy for the operator to move from one position to the other at this control station. The unique feature of this mill is the bead rolling system. It incorporates an electromagnet and a roll-on system which reciprocates over an internal mandrel. With the electromagnetic force from this unit, we are able to do away with the cable that travels all the way back through the mill and is controlled by a pneumatic cylinder. The problem with that system in the old days was that the laser would burn through the cable, and in a short space of time you'd have to stop production to the extent that it just became impractical to bead roll with laser. So with the electromagnet system, we don't have any apparatus passing underneath the laser, and we're able to hold a device inside there which is connected to the mandrel, which is downstream from that. This sensor right here would pick up the mandrel that is out of the home position on the next cycle, and it will shut the system down. As you can see here, we have the control panel, which is a small control panel, operator control panel for the reciprocating bead roll system and a magnet, all combined in one. On the back end of this piece of equipment, we have 2 side rolls to free the mandrel up. They're not designed to totally round the tube from the bead rolling, but they are designed so that it frees up the mandrel from the oval shape. I've incorporated the valving for the hydraulics just above the machine, so it gives the operator and maintenance easy access to the whole unit within this vicinity. Another feature of this mill is the seam grinding unit, which you see right here behind me, and incorporates an oscillating head which actually sands left and right of the seam, and that can be adjusted 5 degrees left or right in case the seam actually rolls over to one side. It also has a pressure adjustment up and down, and it has automatic lift and automatic cool and shut off in the event that you have open seam on the mill as well. It's a wet system. It uses coolant through there and a filtration system just under the mill. Here we have the bright annealing system for tubes, again 1.5 inch through to 4 inch diameter. The system incorporates an annealing box right here with an induction coil using a flexible bus connected to the back of the coil, which generates the power to the induction coil. Through this section here, we have what we call a soaking area. So from 1950 degrees, the tube travels through and is cooled within an inert atmosphere all the way through here. And then the sections that you see down there are graphite cooled, and those are contact positions for the tube. So here we have a non-contact position. Further downstream from that, we have contact position with graphite shoes. In general, the tube temperature here is between 90 and 50 degrees Fahrenheit. By the time it reaches the graphite coolers, it's at about 1500 degrees Fahrenheit, depending on the line speed. And by the time it exits the line, the bright annealing system, it is down to 100 to 120 degrees Fahrenheit. Right here we have the hydrogen and argon inert gas control system, and that incorporates a mixing device where you can change the percentage of gas sometimes for particular materials. We have 5 sections of segmented graphites which are 120 degrees to each other, and they're spring loaded and adjustable to the tube so that it retain contact on the tube to extract the heat from the tube during the process. For a given product, there are cases where we are traveling at a high speed and that temperature reaches as much as 180 degrees, whereby we have to use water quenching behind the bright annealing system. Finally, we have the saw section of the mill. This features a bandsaw, and particularly for bright anneal tube, we chose to have cold cutting method rather than abrasive cut to minimize the dust inside the tube and around the plant particularly. What we've incorporated here was overhead feed for all the utility services, as you can see in these blue posts behind me. And the conduiting for wiring, electrical wiring, air, and in some cases water as well. They all are fed over the top of the mill and come to the various control positions and easy for maintenance to get to. Virtually no cabling or piping laid across the floor, which is a tripping hazard and also an access hazard for whatever personnel are going to be behind the machine. Getting to decide here if you want to do any service on the reciprocator from the back end to deal with the sensors or any kind of maintenance, that's also easy access without having to trip over any items here. Oil service for the hydraulic unit over here. Every item of importance in the magnet is particularly accessible. All the valving for the water cooling, the bus connections for the electromagnets. Moving on further down, you can get to the well box from this position as well and do any maintenance that you need here at the back end of the well box, and also the beam delivery system for the laser. As you can see, I am passionate about what I do. I will invest myself to my fullest ability to achieve the customer's targets in their production, and also incorporate whatever ideas a customer feels necessary. I work closely with a lot of vendors in the USA and internationally, and we will provide the best equipment possible for a particular feature on any line.